program loops, branch and subroutine. Many applications require repetitive operations. For example, the traffic light controller. So the traffic light, even though it will changing, but the process is continuously. Okay, there are 4 major loop constructs. This is for high-level language. Do statement as forever. So without any condition, we will always execute as without condition. And then this one we have a condition. So let's say for I equal to n1 to n2 do s, or for I equal to n2 to n1 do s. Okay, the second flowchart represents the conditions. If the condition is fulfilled, so we have to do S. And if this true, we always do S. Okay, and then next we have while C do S. As long as C is true, so we will always execute S. And the last one, we have to repeat S until C. We will always do S as long as C is true. However, in assembly language, we don't have the instruction like do, while, if, else. We will use a condition code register (CCR) as shaded in yellow color. So we will use either C, V, Z, N, and H as a condition. So what is C flag? C is the carry flag. Okay, whenever a carry is generated as the result of an operation, this flag will be set to 1. Otherwise, it will be cleared to 0. It means when the operations such as the addition, if we have the carry, so the flag will be set to 1. For example, we have instruction ABA. So ABA is A plus B and save in A. So let's say before execution, we have the data A is FF and B is 2, 1. So after we execute addition, FF plus with 2, 1. So what we have here is we will get 1, 2, 0 in hexa. So 1 here represent as a carry because the A register or accumulator consists of only 8 bit. So it just save the data 20 into A. So after A will have 20 and B remain the same value, and then the C flag equal to 1. If the addition does not have any carry, so C will remain the data 0. And then we have V flag. V is overflow flag. Whenever the result of a 2's complement arithmetic operation is out of range, so what we can say is looks like a carry, same as a carry, but the operation includes 2's complement, means include the negative number. This flag will be set to 1, otherwise it will be set to 0. Or if we are not use the 2 complement arithmetic operation, so the V flag is set to 1 when the carry from the most significant bit and the second most significant bit differ as the result of an arithmetic operation. Let's say we use the same data, so we want to use the V We want to determine the V flag. So either 1 or 0. We have to look at the MSB bit and the second MSB bit. Either it is differ or not.
In the overflow flag. So when you have the summation of the addition, for example 7f plus 20 will get 120. Then you have to convert to binary number. Then you will get 1 0 0 1 0 0 0 0 0. And the overflow flag is the bit from the carry from the MSB bit and the second most MSB. So now we have 1 0. So it differs. Then V equal to 1.
Okay, the Z flag. The Z flag is a 0 flag. Whenever the result of an operation is 0, this flag will be set to 1. Otherwise, it will be set to 0. It means, let's say here, we have the data. So Z equal to 0 means no, this is not a 0. So let's say I use the data FF plus with FF. So what is the value? FF plus FF 1FE. So I still get the value 1FE. Means FE is a data, so Z equal to 0. Means it is not a 0. So N is the negative flag. N is a negative flag. Whenever the most significant bit of the result of an operation is 1, this flag will be set to 1. Otherwise, it will be set to 0. This flag indicates that the result of an operation is negative. So it will refer to the here. So it will refer to N. So N here is 0, so it will be 0. And the last one is for H half carry flag. Okay, whenever there is a carry from the lower 4 bits to the upper 4 bits as the result of an operation, this flag will be set to 1. Otherwise, it will be set to 0. So the operation is half of the carry. So if this is the carry, so the half carry is here. Okay. So let's say F plus 1 is 1 0 means we have H. So yes, we have carry, so H equal to 1. So when we use the condition code register for the branch instructions, so we will use in here simple branch taken when a specific bit in the CCR register is in a specific state as a result of a previous operation. Okay, branch instructions. So this condition will be used in the simple branch. Okay, now we have two types of branch. So either short branch or long branch. The difference is when you are doing your mini project, you will get the error like branch out of range. So that means you cannot use the short branch, you have to use the long branch. The short branch is actually for the specific offset value here. Okay, so when we try to recall the instruction, so for the short branch it must be near. For the long branch it can be so far. Okay, this is for simple branch. Simple branch which we use the CCR as a condition. So the instruction for the CCR, let's say if C equal to 0, So we have to use BCC. If C equal to 1, we have to use BCS. B is a branch, C is a C flag, and C means clear. Here S means set. Okay, so when C equal to 0, so we have to use BCC. If C equal to 1, we have to use BCS. And then another one is V. V equal to 0 and V equal to 1. It is same. BVC, C means clear. BVS, S means set. And for N1 and N0, we have to use B branch, BMI or BPL. And for Z equal to 1 and Z equal to 0, we use branch equal or branch not equal. So we cannot use BZC, BZF,